I can find all trigonometric ratios when given only one trigonometric ratio. So we're going to start with the Pythagorean theorem, which only works for what kind of triangles? Right triangles. So if you don't see that this really is a 3, 4, 5 over here on the side, that's okay. It's really a 3, 4, 5 with a scale factor of what? Times 2. So this is going to be 10. If you don't see that though, feel free just to do the Pythagorean theorem very quickly. But you need to be able to find a missing side. So if you don't see it, a squared plus b squared equals c squared. My a, one of my legs, is 6. My b, another leg, is 8. My c is always my longest side. It's over here. I don't know what that is. It's just called ab squared. So you get 36 plus 64. 100 equals ab squared. And if we square root both sides, you get 10 is equal to ab. There we go. Good to go. What about this one over here? You can go ahead and try it yourself. Press pause. Okay, here I go. I don't see a triple, so it's going to be a squared plus b squared equals c squared. And now, you have to be very, very careful. Your longest side is always the hypotenuse. That goes here. Okay, most common mistake, people just put the 9 and the 7 right here, and that's very wrong. You can just say b squared, or you could say bc squared. This is 49 plus b squared is equal to 81. B squared is going to be equal to 32, and we'll square root both sides. Square root of 32, though, is really square root of 16 times 2. And what's the square root of 16? That's 4. What's the square root of 2? I don't know. Still just square root of 2. So it's 4 square root of 2. We're going to need that ability to find a missing side using Pythag today. Okay. Now, yesterday I had a diagram marked up for you, and I asked you sine, cosine, or tangent, and you had to tell me what the sides ratio was. Today it's going to be a little different. Now, before I get to that, do you remember what sine, cosine, and tangent are? You should remember that sine, okay, if we write SOHCAHTOA, we'll just write it right here, SOHCAHTOA. Should go at the top of every page. All right. Sine, if you remember, is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. And tangent is opposite over adjacent. I'm getting that from here. Tangent of t goes here, opposite over adjacent. Those are the ratios we're going to use today. So if I come over here to number 2, take a look what's going on. Something's been given to you. The sine of a is equal to 4 over 5. Now hold on, what's sine again? SOHCAHTOA. So S for sine is opposite over hypotenuse. So if you come down here, what that means is the opposite is 4 and the hypotenuse is 5. But we want to go and be good students. Remember our reference angle and mark everything up. Takes 20 seconds, but it makes a difference. Okay, so now, where's the opposite? The opposite from what? From A. That is 4. The hypotenuse is going to be 5. So what's the missing side over here? How could we find it? That's right, the Pythagorean theorem. Or maybe you remember that this is going to be a 3, 4, 5 triangle. If you see that, that's great. If you don't, use the Pythagorean theorem to find the missing side of a right triangle. I'll just do this only once. Be careful, you had the 4 and the 5. Don't put 4 here and then 5 right here. 5 is the longest, goes over where the C is. Be very careful. That's the hypotenuse. So now you've got 16 plus b squared is equal to 25. Take away 16 from both sides, you've got 9. Therefore, if you square root both sides, b is 3, which we already have. So today, what I really need you to be able to do is to take a given piece of information and put those sides onto the triangle, and use Pythag to find the missing one. So you can try one more time yourself. Okay, here I go. I'll do it real quick. My reference angle is A. My hypotenuse, opposite and adjacent. I'm dealing with cosine, so cosine is adjacent over the hypotenuse. I got that from SOHCAHTOA. Here's cosine. There, adjacent and hypotenuse. So my adjacent happens to be 3, and my hypotenuse happens to be 5, and we already know it's a 3, 4, 5, or do Pythag and realize that this is a 4. So let's go and apply this now. Given that sine of f is 6 over 10, could you reduce that right now? Yes. Maybe you want to. Okay. Let's just pretend you forgot to reduce. So your reference angle is f, and sine, we know, we're always going to write at the top. SOHCAHTOA. Sine s goes to s, so opposite over hypotenuse. Before I get going though, I want to label everything. You do this enough, it becomes second nature. So my opposite from angle F is going to be 6. And my hypotenuse is going to be 10. If you see it's a 3, 4, 5, that's great. If you don't, use your Pythagorean theorem. Do not just put 6 and 10 here. Watch out. This is side FL. The 10 is the longest. It goes over for the C. Let's finish this up quickly. Take 36 from both sides. And you're looking at 64. Square root both sides. And the distance from F to L, or the length of FL, is really 8. There, that's just what we were doing before. Why did we do that? Why did we take this given information and put it on this right triangle? Because now I can ask you any other question about this triangle. For example, what are the other 5 ratios? I could ask you, okay, you had sine of f, but what's cosine of f? What's tangent of f? What's sine of h? What's cosine of h? What's tangent of h? You should be able to do all those right now, like from yesterday's lesson. But for the sake of time, we're going to skip that. And I'm only going to ask you to do this one right here. I'm going to skip to this one. What's cosine of h? So notice your reference angle's changed. Okay? So I'm actually coming from down here. So you might want to resketch the triangle, or just realize now that from h, this is your opposite. This is your adjacent. If you don't like that, if you don't want to like cross these out, that's fine. Make sure you leave the numbers exactly where they are. Numbers and letters stay. And I just built a new one. Take a look how my reference angles have changed. So the opposite and the hypotenuse changed. Sorry, the opposite and the adjacent changed. Hypotenuse stayed the same. Numbers stay the same spots too. So let's figure out what cosine of h is. Cosine is adjacent over hypotenuse. So cosine of h, what's my adjacent to h? 6. What's the hypotenuse? 10. Let's go ahead and reduce and get 3 over 5. I could ask any of the other trig ratios, what's sine of h, what's tangent of h, and you should be able to answer. So in summary, we took a bunch of given information here, put it on our right triangle using trigonometry ratios, used Pythagorean theorem to find the missing side of the right triangle, because we only had 2 to start, not all 3, and then answer the follow-up question, now that we had all three sides, to name another trig ratio. You can go ahead and hit pause and try this mini quiz on your own. Okay, here I go. So, R is my reference angle. Quickly mark up my triangle. Opposite from R. Adjacent to angle R. So let's go ahead. Tangent, if we look at SOHCAHTOA, tangent is opposite over adjacent. So opposite over adjacent here, 24 over 10. Where's my opposite here? This is going to be my opposite is 24. And my adjacent is going to be 10. Now we may have wanted to reduce first because it would have given us smaller numbers to work with. If you didn't do that, you'll just be working with much larger numbers to do Pythag now to find this. If you had reduced first, you could have gotten 12 over 5, and those would have been much easier to work with. But let's say you forgot to reduce, and you define the missing side. A and my B, my legs are going to be 10 and 24. That's 100 plus, and I'll have to go off to the side and quickly do 24 times 24 to see what 24 squared is. That's 16, 8, 9, 8, 4, 576. Okay, so we get 676 is equal to c squared, and we're going to square root both sides. You might be wondering, what is the square root of 676? Well, you might have to go off to the side and experiment. It's certainly bigger than 24, because 24 times 24 is 576. Might be 26, might be 25. But if you go over and then you experiment enough times, you'll figure out what it is. It actually does turn out to be 26. So if you square root both sides, this is 26 right here. And that's actually a 5, 12, 13 triangle. 5, 12, 13 with a scale factor of 2. So if you see that, you save yourself a lot of trouble, or if you could reduce first, you save yourself a lot of trouble. Are we done? No. What's the real question? The real question is, what's the sign of B? Notice they switched the reference angle on you. Tricky. Maybe you want to resketch your triangle quickly. It's up to you. All the letters stay the same. The side lengths, the numbers, they stay the same too. It's just you're coming from B as a reference angle instead of from R. This is still our hypotenuse. This, however, now is the opposite, and this side the adjacent. So sine, we know from SOHCAHTOA, is opposite, which is 10, over the hypotenuse, which is 26. So sine of B is equal to the opposite 10 of the hypotenuse 26, and if I reduce, it's 5 over 13, which happens to be this guy right here, 5 over 13. There you have it. Good luck.